In this video, we will learn about the list data structure. Okay. In the previous video, we learned about the tuple. We learned that a tuple is a heterogeneous, immutable data type that stores an ordered sequence of data. A list is basically the same thing, except it's mutable. Like the tuple, it's heterogeneous and stores an ordered sequence of data, but it also comes with the ability to be partially modified. So, how do we create a list? Well, we know that with the tuple, we create with parentheses. Well, for a list, we create it with a pair of brackets. Then inside those brackets is a comma-separated list of the values you want stored inside that list. After your list is created, we can use indexing to access the individual elements in our list, the same way we do with tuples and strings. Index 0, just like with tuples and strings, 0 refers to the first element in the list. Thus, when we print out the value at index 0, Bob gets output to the screen. Now, unlike a tuple or unlike a string, we can partially modify a list. So there's nothing wrong with me saying, hey, replace the value at index 1 with Tina. This type of statement would not be allowed with a tuple or a string because you can't modify those variables unless you're replacing it entirely. But that's not the case with the list. With the list, you can partially modify it. Thus, when I print out my list as a whole, you'll see the original values, but with the number 20 replaced with Tina. Okay. We can also compute the length of my list. The length of my list will just return the number of values stored inside the list, which right now is 5. This 5 gets printed out. Something else we can do with lists is add values to it. For example, suppose I want to add 35.3 to the list. I would use the append method. The append method will take whatever value you put inside the parentheses and add it to the end of the list. Thus, when I print out my list, you'll see the original values plus 35.3 added on to the end of it. Now, append is useful if you simply want to add a value to the end of the list, similar to how a person can get added to the end of a single file line. However, sometimes our needs are more specific. Sometimes we need a value to be added at a certain location inside the list. In that case, we would use the insert method. In this example, what we're saying is we want the value OMG to be inserted at index 2. That means the value that's currently at index 2, which is 7.5, that value and every value behind it is going to move one space to the right to create space for OMG. Thus, when we print out my list, you'll now see OMG at index 2, and the value that was previously at index 2, as well as all the values that are behind it, have all moved one space to the right. Now, going back to our original list, as you can see, the values inside of it are Bob, 20, 7.5, false, and Kim. We got strings, we got integers, we got floating point values, we got booleans. Now, suppose I want to remove the value at index 1, right? I want to remove the value at a specific location. In that case, I'm going to need the pop method. I will type pop, then inside the parentheses, the index that I want removed. In this case, I want the value at index 1 to be removed, which is 20. Thus, when I print out my list, you'll see each of the original values except 20. As you can see, the pop method is what we use when we want to get rid of a certain value at a certain index. However, what if we want to get rid of a certain value, regardless of where it's located? In that case, we're going to use the remove method. Right here in this example, we want to get rid of the value 7.5. So we type remove, then inside the parentheses, we type the value we want removed. The remove method will then search for that value within the list, then get rid of it. Thus, when we print out my list, you'll see each of the previous values except 7.5. Now, suppose I just want to get rid of the last value. Regardless of what that value is, regardless of how long the list is, I simply just want to get rid of whatever is at the end of the list. In that case, I'm simply going to use the pop method. The pop method will get rid of whatever value is currently last in the list, which in this case is Kim. Thus, when we print my list, you'll see Bob and false, but you will not see Kim. Now, consider these two lists. We got a list named fruits that stores a list of fruits, and we got a list named cars that stores a list of cars. One way these two lists can be combined would be to use the extend method. By stating fruits.extend cars, we're saying take each values in the cars list and add it to the fruits list. Thus, when we print out fruits, you'll see each of the 3 original values plus the 3 values from the cars list. Now note, this statement only modified the fruits list. It did not change the cars list. However, it is possible to do the reverse of this process. For example, suppose I stated cars.extend fruits. Now we're taking each value in the fruits list and adding it to the cars list. Thus, when we print out cars, you'll see the 3 original cars values followed by each value from the fruits list. Once again, in this example, we modified the cars list, but we did not modify the fruits list. Now, suppose I need to search for a specific value in the list. For example, suppose I wanted to know the exact location of cherry inside the fruits list. I could use the index method. Then what the index method will do is search for the first occurrence of cherry inside the list and return the index, which in this case is 2. Thus, 2 will get assigned to X. Thus, when we print it out, 2 will get output. Okay. Now consider this list. As you can see, we have a lot of duplicate values in this list. Suppose I want to count the number of times lowercase a appears in the list. I would use the count method. Letters.count lowercase a will return the number of times that lowercase a appears inside the list, which is 3. Thus, 3 gets assigned to X, and thus when we print it out, 3 gets output. Now suppose we call letters.count b. In this case, it's going to return the number of times lowercase b appears in the list, which is 2. Thus, when we print X again, 2 gets printed out. Now suppose we call letters.count lowercase d, and then assign the number of times that lowercase d appears in the list to X. When we print out X, 0 gets output because there are no lowercase d's inside the list. Python also provides a way for us to arrange our lists in order. We do this using the sort method. The sort method will arrange the list in order depending on the type of values that are in the list. If the list contains strings, as it does in this case, then the list will get arranged in alphabetical order, which you can see when we print out the list. You'll see that the values are now in alphabetical order. Had the list just contained numbers, then it would have got sorted in increasing order or ascending order. For this class, assume that anytime we use the sort method, it'll be on a list that is homogeneous, meaning all the values in that list are of the same data type, aka they're all strings, or they're all integers, or they're all floats, or they're all booleans. Trying to sort a list that contains values that are of different types is an advanced topic that we will not discuss in this class. The last method we're going to talk about is a way to reverse the order of the values, which is simply the reverse method. When you call the reverse method in the list, all the values will get arranged in reversed order, meaning the first value will become last, the second value will become second to last, the last value will become first, so on and so forth. Thus, when we print our cars, you'll see now Volvo is now first, BMW is now last, so on and so forth.